February 20, 1943, north of the Kasserine Pass, Tunisia. General Hans-Jürgen von Arnim confidently watched the Sherman tanks appear on the horizon. For him, it was not a threat, it was a target. The Wehrmacht doctrine guaranteed Americans were slow, disorganized, and dependent on visual orders. What he didn't know was that morning, none of these certainties would survive the dust of the desert, because those tanks weren't moving by luck. They were connected. What the Germans saw as random movements was actually a coordinated network with millimeter precision, where each vehicle knew the position of the others, even if separated by valleys, hills, or kilometers. No flags, no messengers, no line of sight. It was the first time in history that an armored force fought as if it had only one brain, and the Germans, who had always prided themselves on tactical superiority, had no idea how this was possible. This video reveals the technical secret that the Nazis were never able to decipher, the invisible weapon that turned the M4 Sherman into a node inside the world's first combat network. What the Germans called improvisation proved to be engineering. But before we dive into the data, there's one statistic that defines this story better than any battle account. In 1944, American tanks were able to maintain stable communication more than 10 miles away, even on the move, under fire, and traversing valleys. In the same situation, German tanks could barely communicate within 300 meters, an almost invisible difference but absolutely decisive. The Wehrmacht, accustomed to relying on its doctrine and discipline, did not understand why its formations fell apart in the face of American maneuvers that seemed spontaneous, but were actually orchestrated by technology they did not even know existed. If you value real stories, serious research, and facts that change the way we see war, leave your like and subscribe. This helps us to continue to reveal what has long been hidden in the faint signs of the past. Tunisia, February 1943. North of the narrow, dusty Kasserine Pass, German tank engines roar confidently. The Afrika Korps advances under the conviction of tactical superiority. For them, the field is dominated. On the other side, the first M4 Sherman appear. In the eyes of the Wehrmacht commanders, this is not a threat. They are targets. Poorly distributed enemy tanks, far from each other, with no line of sight or conventional formation. But what seemed like vulnerability soon turns to unease. Without any visible warning, 5 Shermans perform a simultaneous flanking movement. No flare is fired. No messengers are seen running between the vehicles. Even so, the tanks reposition themselves as a single organism, covering blind spots and advancing along distinct routes with synchronized timing. A platoon of Panzerkampfwagen I-4 attempts to intercept, but encounters coordinated resistance before it even sees the enemy in full. For the first time, something breaks the German logic. There is no way for a disorganized army to react like this, unless it is operating under a command that they cannot detect. The desert does not speak, but that day, the American tanks were talking to each other with a precision that defied German doctrine. The Wehrmacht's signal officers, equipped with 10-watt amplitude-modulated radios, struggled to maintain contact even within their own platoon. In moving vehicles, the functional distance between German transmitters dropped to less than 400 meters. The Shermans, on the other hand, operating with SCR 508 radios and frequency modulation, maintained clean and simultaneous communication up to 10 miles, even under noise, heat, and combat vibration. The first clue comes from silence. The American tanks do not scream, they do not wave, they do not stop. They just do. And what they do is impossible, according to any war manual of the time. Confusion grows within the German commands. The very nature of American formation seems to escape the pattern. Squadrons that were supposed to be disorganized in the face of the first German attack regroup with surgical agility. The commander of a panzer platoon, perplexed, reports that the Shermans seem to predict the enemy flanks, when in fact they were only responding in real time to information transmitted via radio. The difference between seeing and knowing becomes lethal. The irony intensifies. While the Germans, pioneers of the Blitzkrieg, still rely on tanks with unilateral receivers, unable to transmit orders back to command, the Americans democratize command in the field. Each tank can lead, respond, report. The radio hierarchy is not pyramidal, it is a mesh. When a German commando tank is destroyed, subordinates become deaf. When a Sherman is killed, the others just adjust the mesh and stay connected. In one of the most telling moments of the battle, a fragmented American unit is surprised by an ambush by Panzer IV. 3 surrounded Shermans, with no line of sight to each other, initiate a coordinated evasive maneuver, call for air support, and communicate position to an artillery unit 3 miles away. The answer comes in less than 4 minutes. The artillery hits the German flanks while the Shermans retreat along opposite routes. To the Germans, that seemed lucky, but it wasn't. It was a network, and the network spoke. By 1943, the United States had already standardized the installation of FM radios in 100% of its medium tanks, while Germany was able to equip only 20% of its vehicles with complete transceivers. If this number surprised you, write in the comments, "Logistics wins," because this statistic sums up the invisible change that began there. The war the Germans were used to fighting, fast, visual, tactical, now required something they lacked: integration. At Kasserine, the Americans would still lose positions. Tactically, the victory was German. But there, in the silence among the Sherman tanks, on the invisible waves of the FM frequency, a revolution began that the generals of the Reich could never explain. And most shockingly, even after intercepting clear, coordinated transmissions between American tanks, German intelligence reports insisted on attributing enemy efficiency to rigid training, or unusual discipline for conscript troops. They were hearing the answer, but still they couldn't ask the right question. Instead of investigating the technology, they looked for culprits among their own platoons. The next revelation would bring not only the explanation of the phenomenon, but the name and place where this invisible weapon was created. Because while the Wehrmacht was trying to understand what it saw in Kasserine, the answer was already being mass-produced, on Chicago's quiet industrial lines. In July 1941, as German generals celebrated victories in the Soviet Union and consolidated their lightning warfare doctrine, a small group of engineers on the other side of the Atlantic were quietly redrawing the battlefield. Daniel E. Noble, a physicist trained at MIT, and Henryk Magnuski, a Polish engineer who had recently arrived at the Galvin Manufacturing Corporation, a company that in a few years would become known worldwide as Motorola, were leading the development of a new communication system for the United States Army. The mission was clear: to create a radio that was tough, reliable, immune to interference, and easy to operate under the most extreme conditions of mechanized warfare. The result of this mission was the SCR family of radios, most notably the SCR 508, the first frequency modulation, FM-based tank radio to be produced on an industrial scale. Unlike German technology, which still used amplitude modulation, AM, the American system offered unprecedented clarity. The captain's voice was not drowned out by hisses or swallowed by the noise of the engines. With 25-watt transmit power and per-crystal frequency control, the SCR 508 didn't just cut through the chaos, it organized the chaos. Its operating range between 20.0 and 27. 9 mm allowed for up to 10 preset channels, with enough stability to maintain alignment even during constant bombardment and vibration. In comparison, the German Fu G5, the main radio embedded in the Panzer, operated at 10 watts and relied on tuning by variable capacitors, which made it unstable under combat conditions. The difference was not just technical, she was philosophical. Americans saw radio as an essential part of the weapon system. The Germans still treated him as an accessory of the command. For Galvin Manufacturing, adapting radios to tanks meant reinventing the very concept of electronic mobility. The challenge was enormous. The equipment had to withstand extreme temperatures, NOx, humidity, dust, electromagnetic interference, in addition to the restricted space and irregular power supply inside a moving armored vehicle. Each SCR 508 assembly included the BC604 transmitter, the BC603 dual receiver, a BC606 intercom system, and shielded power cables. The transmitter alone contained 474 capacitors and 385 resistors, all of which were hand-assembled in the first batches. The components were welded, tested, and adjusted with millimeter precision. To keep the frequency stable in combat, the first quartz crystal oscillators with a tolerance of less than 0.01% were developed, a milestone in military electronics. The first units were tested at Fort Knox and showed performance that surprised the designers themselves. For the first time, tanks could maintain clear communication on the move, even under artillery fire. What's more, they could listen and talk at the same time, creating a network of information exchange between units that transformed combat doctrine into something dynamic, adaptable, intelligent. The installation of these radios was standardized even before the official entry of the U.S. into the war. In December 1941, with the attack on Pearl Harbor, the War Department accelerated the contracts. By 1942, 3,800 SCR 508 radios were already in the field. By 1943, that number had jumped to 11,400. In 1944, it exceeded 24,000 units. By the end of the war, total production would exceed 50,000 aircraft. All 49,124 Sherman tanks produced during the conflict left the factory with full radio communications, a 100% coverage rate. There was no exception, and that made all the difference. While Germany struggled to equip at least 1 or 2 tanks per platoon with full radios, and had to decide which vehicle deserved the privilege of broadcasting, the United States ensured that every vehicle was a potential command point. Radio was no longer the final link in the chain. It was the center of the strategy. The difference was evident not only in the coordination of attacks, but in the ability to improvise. In an American force, if the commander fell, the replacement was already listening. If the formation was reached, the remaining units reconfigured instantly. Such autonomy was unthinkable in a doctrine that relied on vertical and visual orders. And once again, historical irony loomed large. The Germans, who had pioneered military radio in World War I, and whose theorists like Guderian championed radio as the essence of armored warfare, now found themselves overtaken by American industrial standardization, done not by generals but by civil engineers and factory workers in Chicago. In Germany, production of Fuji-5 radios was limited to about 6,000 units throughout the entire war. In America, production of the SCR 508 was 10 times higher, a quantitative difference that generated a qualitative revolution. For every 1 complete radio that Germany produced, the U.S. delivered 10 and installed them in vehicles that left the factory ready to operate in a network. But perhaps the most symbolic data is not in the numbers but in the words. In 1944, a German officer captured after the Battle of St. Lo was interrogated about the American performance. His answer was simple: they don't have better tanks, they just know where each other is. This perception, although late, anticipated what modern military manuals would only admit decades later. The war would be won by whoever communicated better, and this new war was already being shaped. Because while the SCR 508 radios revolutionized combat on the move, another, even more critical flaw was about to emerge. German doctrine, no matter how sophisticated, could never survive if the structural basis of its own platoons was doomed to silence. And this failure would come to light in the cruelest way, the moment the commander was destroyed, and no one else knew what to do. In 1937, when Heinz Guderian published Achtung, Panzer, he established the fundamental principles of modern armored warfare. At the center of his doctrine was radio. For him, it was not enough to have fast, well-armed tanks. They needed to communicate with each other in real time. The blitzkrieg that swept through Poland, France, and the Soviet steppes would not have been possible without the presence of radio and command tanks. On paper, Germany had understood before any other army that mobile communication was the new blood of war. But by 1943, that vision was being shattered by the very system that created it. The German war industry, stifled by bombing, material shortages, and a fragmented industrial structure, could not keep up with its own doctrine. The Fuji-5 radios, which were to equip all Wehrmacht medium tanks, were expensive, time-consuming to produce, and relied on sensitive electronics that were in short supply. The result was a quiet collapse. Most panzer platoons operated with only 1 or 2 tanks equipped with full transceivers. The others had at most Fuji-2 receptors, capable only of hearing. On the field, this meant a one-way chain of command, extremely vulnerable. A well-aimed blow to the command tank, usually identified by the multiple antenna, was enough to paralyze the entire unit. The subordinate tanks, lacking the ability to respond or report, were stuck with the last order received, unable to improvise or regroup. The radio, which should have been the link of adaptation, became a tactical trap. The difference between theory and reality was stark, and once again, historical irony imposed itself. The architect of the Blitzkrieg had been betrayed not by his enemies, but by the industry that failed to sustain his own vision. In a memorandum dated December 1944, Already as Inspector General of the Armored Troops, Guderian would admit that communication failures were compromising the effectiveness of the panzers, even when they had superior weapons and armor. But by then, the diagnosis no longer mattered. The disease had spread. In real confrontations, the disability became fatal. In battles such as Kharkov, Kursk, and the defensive battles in Italy, German tanks often started combat with mission clarity, but the loss of a commander was enough for the platoon to disassemble. There was no way to report enemy positions, call for artillery support, or coordinate retreats. Silence became a sentence. On the other hand, the Americans began to operate with a completely opposite logic. The Sherman's FM radio was not a command privilege. It was factory standard. Any crew could report, coordinate, react. American doctrine allowed tactical leadership to emerge from the field, not just from the hierarchy. This flexibility, impossible in the Wehrmacht structure, created a new kind of armored force, less rigid, more adaptable, always connected. And it was this invisible cohesion that began to erode the panzer's efficiency. It didn't matter how many millimeters of armor a Tiger II possessed if it didn't know where the enemy was. It didn't matter the rate of fire if no one told you when and where to shoot. The absence of communication turned war machines into isolated, powerful, but disoriented fortresses. The failure was not only technical, it was systemic. The German high command, embroiled in internal disputes, underestimated the real impact of the communication failure. Resources were diverted to increasingly complex and heavy tanks, such as the Panther and King Tiger, while the communications infrastructure remained virtually stagnant since the beginning of the war. The priority was the cannon, not the connection. Weapons engineering was advancing, but the doctrine that depended on coordination was weakening. For the American industry, the path was reversed. Serial production, organized under strict contracts and standardized processes, allowed the manufacture of radios to scale in direct proportion to that of tanks. Galvan manufacturing didn't just supply the SCR-508s, they delivered them tested, packaged, and numbered for immediate integration into the assembly lines of Chrysler, Ford, and Fisher Body. Radios were not accessories. They were part of the vehicle's DNA. The result was an army where each tank was also a transmitter. Each platoon was a living mesh, and each commander, a node of information. For the Germans, the defeat was not only on the ground, it was in logic. In interrogations conducted by the U.S. Army in late 1944, several Panzerwaffe officers admitted bewilderment at the American responsiveness. One of them, when trying to describe a failed counterattack in Normandy, summed it up. They flanked us before we knew they were there, and when we reacted, they were already somewhere else. What he didn't know was that by the time his platoon decided to move, the Americans had already broadcast their position, drawn up the plan, and requested fire support. Modern warfare was no longer about strength. It was about time, and time was controlled by who could speak first. By the end of 1943, British intelligence estimates indicated that less than 40% of German medium and heavy tanks were equipped with radio transceivers. In the U.S., this number already exceeded 95%. The difference was not just numerical, it was historic, because while German war theorists were writing about the power of communication, Americans were building, welding, and distributing that power in every cubic inch of metal, and they wouldn't stop there. The next big turning point would come not on paper nor in speeches but in the mountainous fields of Italy, where the absence of line of sight and the brutality of the terrain would test what it really meant to fight on line. When the first Sherman tanks equipped with the SCR-508 crossed the Atlantic and landed in North Africa, they didn't just bring steel, ammunition, and fuel, bringing with them 181 pounds of circuits, transmitters, receivers, and shielded cables. They carried a new concept, that of a mechanized force that was not just mobile but interconnected. For the first time in the history of warfare, each combat vehicle was more than a machine. It was an autonomous node within an active network of tactical information. With 25 watts of power, a stable frequency between 20.0 and 27.9 mmHz, crystal control, and 10 preset channels, the SCR-508 allowed American tanks to share orders, alerts, and coordinates in real time, without the need for a visual signal or physical proximity. But its real differential was in the use of dual receivers. With them, each platoon commander could simultaneously listen to two different networks, his local tactical chain and company command, or, in some cases, even the artillery or advanced infantry. This turned the Shermans into mobile command centers, decentralizing decision-making power and allowing tactical maneuvers with an unprecedented degree of freedom. The contrast with German reality could not be more cruel. Panzers still operated under vertical logic, with the commander transmitting orders that subordinates received, but never responded. This made each unit overly dependent on a single link. If the link fell, the peloton fell silent. The Americans had already created a system where any node could assume temporary leadership and reorganize formations. The difference between an army organized by columns and one connected in a mesh began to appear on the field with devastating results. In one episode reported by British officers observing American operations in Italy, a group of Sherman tanks was separated by more than 3 miles of rugged terrain, with valleys, rivers, and steep slopes. Even so, when ambushed by German anti-tank guns hidden in the forest, the Shermans were able to regroup, coordinate a flank response, and call in artillery support, all without visual contact. The action lasted less than 7 minutes. The irony of this story is that the solution was in front of them. The Germans had always believed that their doctrine would be sufficient to maintain superiority on the battlefield, but they failed to recognize that they were fighting something more sophisticated than doctrine. They were facing a distributed combat architecture, sustained by radio waves. And it is precisely this invisible network that has begun to change the game. Motorola's engineers had designed the SCR-508 with a first-of-its-kind industrial philosophy, modularity, and compatibility. This allowed different units, even from different battalions, to integrate into the same network without the need for time-consuming adjustments. It was enough to align the predefined channels and the voices became one. This interoperability turned warfare into an environment where flexibility was weaponized. Platoons could be mixed, tasks redistributed, formations reorganized, and all of this happened without bureaucracy, without fragility, and without hesitation. Radio became the gravitational center of American doctrine. It was no longer the tank that determined the maneuver. It was the ability to communicate between tanks that allowed the maneuver to exist. And this principle became even more evident as Americans faced hostile conditions such as mountain fogs, dense forests, or inconspicuous terrain. In these situations, the Axis forces found themselves trapped in the visual model, flags, gestures, and assumptions. The Americans operated for information. An emblematic example occurred during the Monte Cassino campaign in 1944. While panzers relied on fixed-line communication between battalions, often cut off by bombardment, Sherman tanks operated in sync with artillery and infantry, even under hail and mud. The coordination was so precise that the British allies themselves, accustomed to more centralized doctrines, commented that the Americans seemed to have eyes in places where no man could be. That was the real revolution. Not to win by force, but by listening. Not to dominate by size, but by connection. The radio is no longer a peripheral accessory. It became the very heart of the operation. Every voice in the field wasn't just a command. It was collective intelligence operating in real time, and that engendered a new kind of trust. A crew could move forward even without knowing where their commander was because they knew that in any direction, there was an active mesh listening, responding, protecting. If you're enjoying unraveling these facts hidden by the dust of history, show your support, like and subscribe. This helps us continue to bring content with the same precision with which the Shermans spoke to each other. By the end of 1944, American superiority in radio coordination was so widespread that it was already beginning to have a psychological impact. Wehrmacht intelligence reports mentioned, with concern, the ability of the Americans to act as one body, even dispersed. But what the Germans did not yet know was that this cohesion was only the beginning, because soon they would discover that, contrary to what they believed, Americans' greatest weakness, decentralization, was actually their most lethal strength. And this would be evident the moment the first German tank saw its flanks being attacked by units that it didn't even know were there, responding to an order that would never be heard. In theory, the German tank was a superior war machine. The Panzer IV possessed respectable firepower, robust armor, and well-trained crews. But there was a structural detail that did not appear in the technical sheets, and that, on the battlefield, became fatal. Most of them were mute. In a typical Wehrmacht platoon, Only 1 or 2 tanks carried Fuji 5 transceivers, equipment capable of transmitting and receiving messages. The others, at most, were equipped with Fuji 2 receivers. This meant that, in practice, only the commander could speak. Everyone else just listened. They could not respond, report threats, or suggest a flanking route. And if the command tank was destroyed, which was common because it was easily identified by multiple antennas, the rest of the unit lost its ability to coordinate at the same time. The chain of command was broken, and with it, the cohesion of the platoon. The radio that had once been a symbol of the blitzkrieg had become a single point of failure. In contrast, the U.S. military had systematically eliminated this risk. All 49 324 Sherman tanks produced during the war were equipped with full transceivers. Each vehicle could communicate with any other, regardless of position in the hierarchy. If the commander was shot down, the tank next to it took over. The decision-making power was distributed. German doctrine still operated under a vertical logic, inherited from previous wars. Commanders transmitted orders, subordinates executed. The Americans had already created a combat ecosystem where the decision could emerge from local tactical necessity and be communicated instantly to the entire network. That changed everything. In an ambush, for example, a German tank could see the enemy approaching, but if it weren't for the command vehicle, it couldn't warn anyone. In the accounts of the battles at Anzio and Monte Cassino, there are repeated situations where entire German formations hesitate to react, even in the face of a visible threat, simply because they were waiting for orders that would never come. When the commanders fell, the silence was absolute. The Shermans, on the other hand, even in disorganized formations, reacted as if they were under one mind. In 1944, during a series of engagements on the outskirts of Carentan, an American patrol intercepted German transmissions. All they heard was static. There was no sign of active command. The few working radios were overloaded and inefficient. Messages took time, were truncated, or were lost in the noise. Meanwhile, the Americans coordinated the advance clearly, switching between predefined channels, reporting enemy positions, requesting fire support, and updating maps in real time. The American system worked even under pressure, and so German pressure no longer had any effect. The decline in German tactical effectiveness was not due to a lack of armament, nor to a lack of courage. The collapse came from silence, a technical, structural, and doctrinal silence. Radio production in Germany had become a chronic bottleneck, with incessant bombardments of factories, a shortage of rare metals, and shortages of electronic components. Few G5s have become luxury items. The High Command chose to equip the command tanks and SS units first, relegating much of the regular formations to passive communication. It wasn't a strategic choice, it was industrial survival, and this delay accumulated. By 1943, the U.S. had already produced more than 11,000 SCR-508 radios. Germany, in the same period, barely surpassed the 2,000 Fuji 5 transceiver mark. This ratio, almost 6-to-1, translated directly into maneuverability. What the Germans called American improvisation was actually a deliberate system of built flexibility. The historical irony was in every field report where German commanders tried to explain how the Shermans responded so quickly. They attributed it to excessive tactical freedom, unorthodox behavior, or even aggressive casualness. They did not understand that they were facing a network. On the field, the effects were devastating. In the Allied advance through France, German formations were systematically dismantled not by brute force but by confusion. Troops received outdated orders, tanks waited for commands that never arrived, and reinforcements moved without knowing that the scenario had changed. Radio warfare didn't appear on the maps, but it defined every front line. A document captured in September 1944, coming from the 10th Panzer Division, expresses frustration involuntarily. The Americans seem to operate with eyes in all directions, even when scattered. Their formations are disorganized in appearance, but they move as if they share the same mind. It was a veiled acknowledgement that the traditional doctrine had been superseded by something new, a kind of coordination that required neither physical proximity nor centralized command. It was the beginning of a new kind of warfare, where radio not only connected tanks but shaped decisions. And most worryingly, even when intercepting American transmissions, the Germans could not decode the essence of the system. They thought it was just a matter of technical clarity. They did not understand that it was a philosophy of combat, built piece by piece. on the production line. What Germany had lost was not only technological superiority. He had lost the initiative, because the moment the enemy can react before you decide to act, the war is lost even before the shot. And the next great battlefield, a territory where no line of sight was possible, and where German doctrine would be put to the test, would reveal this in the cruelest way. On the mountain, those who do not hear do not survive. In the dust of the African desert, the mountain valleys of Sicily, and the smoldering ruins of Italian villages, a pattern began to emerge, but the Germans didn't know what to name it. It was as if American tanks, particularly the Shermans, had acquired the ability to be in two places at once. In 1943, on the outskirts of Gafsa, Tunisia, the 10th Panzer Army encountered for the first time a phenomenon that, in the following months, would recur with disconcerting frequency. Fragmented, dispersed, poorly positioned American units, according to German doctrine, suddenly converged with impossible precision. Sometimes two platoons would join at angles of attack with no line of sight between them. In others, Allied artillery opened fire with surgical precision seconds after a column of panzers was detected by a single American tank. German commanders began recording these episodes in after-action reports. The word disciplined began to appear with unexpected frequency, usually accompanied by phrases such as unusual coordination, quick responses to contact, or synchronized movement without visual cues. The official explanation in the documents of the 10th Panzer Division was that the Americans had exhaustively trained their crews in coordinated maneuvers, but something didn't add up. No level of training explained the speed of the reactions, especially under fire. No rigid doctrine explained the elasticity of counterattacks. What the Germans were witnessing was not doctrine, but invisible architecture. Behind every maneuver, every synchronized response, was the SCR-508 radio. Fitted as standard on every Sherman since 1942, this 181-pound radio operated at 25-watt power, crystal-controlled frequency, and frequency modulation, technology that eliminated interference and allowed clear communication, even when moving over rough terrain. In practice, this meant that a tank hidden behind a hill could detect the enemy, and in less than 10 seconds, warn his entire company, including the artillery. A German platoon in the same situation needed its commander to identify the threat, transmit via 10-watt AM radio, subject to static, and wait for headquarters to relay the message. On the field, this difference translated into minutes, and in war, minutes kill. In Monte Cassino, February 1944, the phenomenon became undeniable. German forces, defending high positions, were confident that the mountainous terrain would limit the Sherman's effectiveness, but that was not what happened. American troops were able to coordinate movements between units separated by mountain ridges and deep valleys. While the Germans relied on sightlines or messengers, the Shermans exchanged information as if they were in the same open field. The SCR-508's ability to handle multipath interference, caused by signals reflected off valley walls, proved decisive. What's more, its predefined channels allowed switching between local communications and command orders instantaneously. American radio turned the Italian battlefield into a three-dimensional maneuvering space, while the Germans remained stuck in a two-dimensional front-line logic. Most disturbing to the Wehrmacht commanders was that they often did not even know they were being watched. In Palermo, German reports mention American movements with advance awareness of our positions. Espionage or leaked documents were supposed, but the reality was simpler and more unsettling. The Shermans were communicating with each other in real time, triangulating positions, synchronizing actions, updating information, without ever having to break the silence of the visual field. The radio had become a weapon, and its impact was psychological as well as operational. In several intercepts made by Wehrmacht intelligence, German technicians were surprised by the clarity of the American transmissions, not only because of the absence of noise, but because of the structure of the dialogues. Quick, direct commands with radio operators reporting coordinates, movements, and requests, with a naturalness that suggested habit, not exception. For the Germans, this was frightening. A report from the intelligence of the 10th Panzer Division dated May 1944 states, American armored units maintain constant and clear communication during combat. There seems to be transmission going on between all vehicles, not just command vehicles. It was the tacit recognition of a rupture in the way war was waged. It was no longer just about cannons and armor, but about data, voice, synchronization. The irony of this story is that the solution was in front of them. Germany in the 1930s had led the use of radios in tanks. Guderian was an early advocate of armored communication as a tactical tool, but by 1944, his own doctrine was being defeated by the superior execution of his enemies. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can continue to bring you more in-depth content about the invisible gears of war. The Sherman's sense of omnipresence was not a miracle nor a coincidence. It was engineering applied to tactics. Each tank was not an isolated point, but a node in a flexible tactical network, a concept that would later be called network-centric warfare. The Germans didn't know this, but they were already fighting against the future, and the future was winning. And if the tanks could talk to each other, what would happen when they also talked to the infantry? When ground coordination expanded to the entire front, including foot soldiers, artillery observers, and air support, this connection, or its absence, would define the next shock. Soon Germany would discover that being blind was bad, but being deaf, in the face of an all-hearing enemy, was worse. July 1944. The plains of Normandy, still scarred by the wreckage of D-Day, became the scene of an unprecedented display of military coordinating power. It was the beginning of Operation Cobra, and with it, the U.S. 2nd Armored Division launched more than 200 Sherman tanks in an attack that not only broke through German lines, but also the tactical logic of the Wehrmacht. Until then, the Germans still harbored a belief that the American numerical advantage was compensated by its operational slowness, supposed disorganization, and lack of flexibility in the face of German attacks. But what they saw that week was something different. The battlefield became an organism in motion, where platoons redistributed in real time, responding to threats with speed and precision, impossible to explain by discipline or luck alone. A tank spotted an enemy position, transmitted the location in seconds, and artillery opened fire with surgical precision. Another, separated by kilometers, modified its route to intercept a counterattack, even before it came into eye contact. The secret was in the radios. Each of those 200 Shermans had their own SCR-508 transceiver, and they all operated as if they were part of a single consciousness. Radio was no longer a channel of orders. It was the very architecture of strategy. Germany, in turn, still operated with a hierarchical and centralized logic. In a typical German platoon of 5 tanks, only 1 or 2 vehicles had transmission capability. The others could only take orders. All it took was one command tank to be destroyed, and the entire unit collapsed in silence. The Blitzkrieg doctrine, based on speed and flexibility, had become dependent on a communication structure that did not keep up with the reality of the field. While the Americans multiplied their radio channels, Germany sank into scarcity. By 1944, the U.S. had produced more than 24,000 units of the SCR-508, equipping virtually all Sherman tanks with full radium. Germany, in the same period, produced about 6,000 units of the FUG-5, a less powerful radio, with a shorter range and extremely susceptible to interference. Only 20% of German medium and heavy tanks entered combat with complete communication. Pause. If this statistic surprised you, write it in the comments. Absolute power, because in practice, that's what connectivity delivered. American tanks could see, hear, and respond like a network. The German tanks, despite their superior armor, were isolated and deaf. During Operation Cobra, this difference became unbearable. With the German defenses disorganized after aerial bombardments, the Shermans advanced like a tide. But what confused the Germans wasn't speed, it was accuracy. They expected uncoordinated attacks which could be intercepted in blocks. But the Americans adapted in real time. If a road was blocked, 3 platoons had already redrawn the route and repositioned its flanks. If an ambush was detected by a reconnaissance tank, the coordinates were transmitted before the combat even began. It was like fighting an enemy with eyes in all directions. American artillery, equipped with observers connected directly to tanks by radio, struck targets with a speed and efficiency that turned entire battles into decisive minutes. A German unit could be detected, fixed, bombed, and surrounded before it could even transmit a request for reinforcement. The Wehrmacht wasn't just being outclassed in armor or numbers, it was being suffocated by something it couldn't see: the net. The irony was cruel. Germany, which had inaugurated the military use of radio in the 1930s, now found itself reduced to dependence on limited, scarce, and outdated radios. And the doctrine of superior tactics crumbled in the face of a war in which every American tank was potentially a command center. Major General Edward H. Brooks, commander of the 2nd Armored Division, described the operation as a steady stream of adaptation and response. What he didn't say publicly, but what his internal reports recorded, was that this flow was possible thanks to full interoperability between the radios, the pre-configuration of channels, the frequency stability of the crystals, the dual receivers that allowed simultaneous listening of different networks. All of this converged to create a combat system in which knowledge circulated faster than bullets. The American Blitz wasn't just about steel and fire, it was about data. A German soldier captured after the battle reported that American tanks appeared where we least expected it, and always in sync. He didn't know it, but the radio was there even before the tanks arrived. The collective mind of the operation had already processed his presence. Cobra was a turning point. From it, it was clear to the German High Command that battles were not only being lost in the field, but in frequencies. The Oberkommando der Wehrmacht began investigating the radio capabilities of the Americans. But it was too late. The technological backwardness had become structural. The American network was a product of industry, but also of philosophy. While the Germans concentrated power in elite units, the Americans distributed capacity throughout the force. Each Sherman had decision-making power. Each radio was a bridge between units. Coordination no longer depended on a general. It depended on connection, and if the tanks were all connected, and if they could talk to each other, and if they also began to connect to the infantry in the air, what would come next? Soon the Germans would discover that losing the battlefield was only one of the consequences. The next revelation would come from the sky, and she would speak at the same frequency. To the German military mind, shaped by Prussian precision and the unshakable belief in the superiority of doctrine, the enemy was always inferior. Victory was a matter of method. When the Americans landed in North Africa, then Sicily and Italy, the reports of the German High Command repeated the same descriptions. Inexperienced mechanized forces, scattered formations, soldiers dependent on strict orders, and an obsession with electronic equipment. The reading was clear. The Americans were trying to compensate for their lack of military tradition with machines. For officers like von Arnim and Model, this dependence on the Americans was seen almost as a weakness, as if technique was replacing instinct. But what they saw as improvisation was actually architecture, and what they called rigidity was, in practice, a distributed network that defied the classical laws of command. Still, even in the face of successive defeats in operations such as Avalanche, Anzio, and Cobra, internal Wehrmacht reports rarely mentioned radios as a decisive factor. When Shermans appeared where they shouldn't be, the explanation was well-trained advanced reconnaissance. When flank responses were too quick, it was attributed to platoon aggressiveness. When American artillery fell in the right place, seconds after detection, the conclusion was overuse of front observers. In none of these reports was it recognized that the common link between all these phenomena was communication. Blindness was not tactical, it was epistemological. Germany could not perceive radium as a weapon because its doctrine did not consider it a vector of decision. To them, war was a game of position, armor, fire, and command. The radio was a support, not brain, but the Americans had reversed this logic, and in doing so they created something new, an army where information flowed at the speed of electricity. In a post-war study conducted by British intelligence, a set of documents captured from Heeresgruppe B was analyzed, in which officers tried to understand the American advance in Normandy. One particular passage caught the attention of historians. The mechanized forces of the U.S. appear to operate with an abnormal uniformity, even without physical concentration. We assume that they are using movement doctrine based on predefined procedures. It was the attempt to explain the inexplicable without breaking the paradigm. The idea that the Shermans were connected by a stable radio mesh, where each crew member was a live antenna, was not even considered. It was as if the German doctrine did not have the technical or philosophical vocabulary to see the nature of what it faced. And when you don't understand a threat, you don't adapt to it. Germany had built its war machine based on localized excellence. The best tank, the best division, the most audacious commander. The Americans, on the other hand, were building a systemic force, where the whole mattered more than the sum of the parts. And in this system, the radio was not an accessory. It was tactical infrastructure. Modern warfare was not born in the roar of the cannon, but in frequency. And the most serious, even when the Germans intercepted American transmissions, they did not know what they were hearing, because the clarity, speed, and modularity of the command seemed something out of the tactical reality they knew. American superiority was on the ground, but it was also hidden in the waves that streaked through mountains, forests, and cities, invisible, and precisely for this reason, misunderstood. American radio didn't just allow for quick maneuvers, it allowed you to think about combat speed. He anticipated, reacted, updated, and Germany, stuck in its own tradition of centralized command and unilateral orders, simply did not have the structure to understand what it was facing. Their tanks could have superior armor, your crews, more experience. But none of these qualities mattered if there was no living coordination between them. The system did not react as one body. And on the field, a body that does not respond to its own injury dies. In August 1944, General Fritz Bayerlein, commander of Panzer Lehr, wrote a report after the devastating defeat at Mortain. In it, there is a phrase that defines the German tragedy better than any later analysis. The American mass is not only numerous, it is cohesive, as if commanded by a single hand, even if that hand is never visible. It was the involuntary confession. They didn't know what it was, but they knew they couldn't beat it, because you can't defeat what you can't see. The doctrinaire arrogance of the Wehrmacht, so sure of its technical superiority, had ignored the most revolutionary factor of the war, connection. And while she ignored it, she was overcome. And while she underestimated, she was defeated. But the biggest surprise was yet to come, because if the American tanks were already lethal with their voices, what would happen when these voices began to extend to the sky? When radios started connecting not only vehicles but fighter planes, bombers, and aerial reconnaissance in real time? The next chapter of the war would not be fought on land. It would be drawn in the air, and it would speak at the same frequency. On the narrow roads and in the fields enclosed by the dense vegetation of Normandy, the Sherman tanks advanced slowly, not for lack of power, but for lack of blindness. Operation Overlord had violently broken the defenses of the French coast, but the real nightmare began inland. The hedgerows up to 3 meters high, with deep, thorny roots, that formed a natural labyrinth impossible to cross without full exposure. In these green corridors, tanks have become vulnerable, but not because of the enemy presence, by the absence of communication with his own allies. The U.S. infantry, equipped with SCR-300 radios, lightweight, versatile, but operating on VHF, could not communicate directly with the tanks, whose SCR-508 radios operated on FM UHF. They were modern technologies, but they did not speak the same language. And in the countryside, that meant disasters. Foot soldiers could not warn the Shermans of mines, ambushes, or booby traps. Tanks advanced without knowing what was ahead, or stopped waiting for orders that would never come. On more than one occasion, Shermans accidentally opened fire on U.S. troops due to a lack of coordination. The scene repeated itself. A platoon surrounded in a field, trying to signal with gestures to the nearby tank, while the commander, isolated in the steel hull, listened only static. The war of communication which the U.S. had won against the Germans now threatened to be lost against itself. The first solutions came from below, from raw necessity. In units of the 2nd Armored Division, soldiers began to improvise. With repurposed radio parts and manually welded wires, they installed hull phones, external devices attached to the rear of the Shermans, which allowed the infantry to communicate directly with the tank's crew. All the soldier had to do was raise the phone, press the button, and talk to the commander. It was not elegant, but it worked. The idea spread like wildfire. In a matter of weeks, the Army made the modification official, standardizing the model as the M1919 tank infantry telephone. With it, interoperability between the nodes of the network began to recover. Now, the tanks were not only a network between them, but also a bridge with eyes and ears on the ground. The speed with which this flaw was identified and corrected shows the degree of technical maturity of the American war machine. In any other army, such an interoperability failure would require months of meetings, testing, and approvals. In Normandy, it took only weeks. Field officers reported the problem, Base engineers improvised the solution, and Logistics Command responded with massive production and distribution. By August 1944, more than 60% of Sherman tanks in operation in France were already equipped with hull telephones. The impact was immediate. In operations such as the retaking of St. Lo and the crossing of the Vire River, direct communication between tanks and infantry reduced response time by up to 70%. Coordination between forward observers, fleet sergeants, and armored vehicle commanders began to occur in real time. Ambushes were avoided. Friendly fire plummeted. For the first time, the entire American fighting force, tanks, infantry, artillery, operated as a single living network. Germany, for its part, watched everything without understanding. In the captured accounts of prisoners of the 17th SS Panzer Grenadier Division, there is bewilderment at how American units knew exactly where we were, even without seeing us. A German officer detained at Chambois confessed that his men were convinced that the American tanks possessed some kind of ground-based radar. The truth was simpler and more lethal. The tanks were listening to their own soldiers. Modern warfare had reached a new height. It was no longer enough to have good radios. It was necessary for them to understand each other, and the U.S. learned this quickly. Interoperability has become doctrine. The new radios, such as the SCR 528, were designed with dual channels for communication with tanks and infantry. The commanders received specific training to operate in an integrated manner. And, more importantly, the philosophy behind network warfare has been extended to all levels of the hierarchy. There was no longer any division between those who commanded and those who saw the field. Everyone spoke, everyone listened, everyone decided. The lesson was brutal. Even the best technology is useless if it doesn't connect the men who use it. And the Americans, more than any other army at that time, understood this. Germany, for its part, had not even realized that this problem existed. Its tanks still operated in isolation, their infantry guided by pennants, hand signals, or messengers on horseback. In the open field, this was already a delay. In the labyrinths of Normandy, it was suicide. Interoperability, that almost invisible concept, was deciding battles. The war was no longer about who had the best tank. It was about who listened better. And the United States didn't just listen, they reacted. But if the American tank now listened to its infantry, and if the infantry spoke to the artillery, who would be the next to join this network? The answer would come from the sky, not as bombardment but as coordination. The next enemy to fall would not be an armored division. It would be the distance between soil and air. Between July and September 1944, what was left of the German offensive on the Western Front began to crumble, but not under the weight of an explosive defeat, as in classic battles, but as a machine that slowly loses each of its axes. The Wehrmacht was being dismantled from within, and the corrosive agent was silence. After Operation Cobra, the strategic initiative changed hands. The Allies, now with operational freedom, launched in-depth offensives, and in doing so, began to destroy not only military targets, but also the enemy's communication arteries. Underground telephone lines were cut by commandos or tactical bombings. Command posts were identified and annihilated by P-47 fighter bombers with direct assistance from American forward observers, radioed to the ground. The impact was devastating. The Germans, already scarce in mobile radio, found themselves unable to reorganize lines or react to advances. The German doctrine, based on maneuver warfare and the principle of Auftragstactik, the autonomy of local command, was betrayed by its own technical incapacity. The commander of a Panzer IV tank company, operating on the outskirts of Mortain, received orders by courier on a motorcycle. When he reached the rendezvous point with his support force, he found only wreckage. The tanks had been destroyed hours earlier by Allied planes. Without a radio, he didn't know. Without a radio, he did not retreat. It was surrounded. At Mortain, the German offensive to cut through the Allied lines and regain Avranches was launched with ambition, but without coordination. The armored units advanced with courage, but without mutual communication. Each group operated on the basis of fixed schedules, outdated maps, and printed orders, vulnerable to any changes in the field. When the first tanks broke through the American defenses, they expected to find support in the rear. There was no one. The other columns, delayed or destroyed, failed to warn. The Americans, on the other hand, knew exactly where each German column was. Advanced observers transmitted position, speed, and direction in real time. Within minutes, artillery and fighter squadrons were already in the air. In a matter of hours, Mortaine's offensive collapsed. Silence, more than any bomb, was what killed the attack. In Falaise, days later, the pattern was repeated. The German retreat, pressured by 3 Allied fronts converging on the pocket, turned into a massacre. German troops, disconnected from each other, tried to open escape corridors, but each attempt was uncoordinated, hasty, doomed. The remaining tanks did not know where their allies were, where the enemies were, nor where they should concentrate their fire. The order to withdraw was given late, and, for many, it never came. What should have been a tactical maneuver has become a corridor of destruction. More than 10,000 soldiers killed, 50,000 captured, and about 350 tanks and armored vehicles lost, all because the Wehrmacht could no longer hear itself. Radium, that invisible element, now became the line between life and collapse. While the Shermans communicated with each other, with the infantry, and with the sky, the German tanks operated in the dark, each as an island. A platoon commander of the 2nd Panzer Division wrote in his diary, "Today we received orders to advance. On the right, nothing. On the left, silence. We don't know if there's anyone there. We continue anyway. It's like moving forward in a fog of steel." This testimony reveals Germany's operational drama. It was not just a military defeat, it was a functional dissolution. The doctrine of lightning warfare, which had dazzled the world in 1940, depended on nimble communication, quick responses, and decentralization, exactly what obsolete and scarce radios could no longer offer. The FUG-5 radio itself, still standard on medium tanks, had limited range, sensitive to interference, and only allowed conversations between vehicles of the same company. With few active transceivers, the destruction of a command tank was enough for the network to disappear. In contrast, the Americans distributed radios redundantly. In each platoon of tanks, at least 2 or 3 vehicles could transmit. In addition, each company had access to multiple channels, allowing cross-communication between armor, infantry, and air support. The American structure was made to withstand losses and still function. The German one did not, and when the system breaks, even the best soldiers become static targets. The irony is brutal. The Germans, who had started the war with the most advanced doctrine of mechanized coordination, ended up fighting as if they were back in 1918, running back and forth without knowing where the Allies were. The absence of radio was no longer a technical detail. It was a structural poison, silent, corrosive, invisible, but lethal. And while the Germans tried to patch up their broken system with courage and discipline, the Americans forged ahead with a new kind of power, the collective conscience, a force that listened, that responded, that acted as one body. In every advance, every thwarted ambush, every successful siege, there was an invisible signal in the background. Radio waves. They didn't just connect tanks, they shaped the war. But the most impressive thing was yet to come. Because if radio had already become the backbone of the American army on the ground, what would happen when those same waves began to guide fighters, bombers, and entire squadrons into the European sky, in real time? The answer would redefine the concept of air supremacy. September 1944, plains of Lorraine, northeastern France. In Aricourt, an unequal confrontation was about to take place. On one side, the newly arrived German 5th Panzer Division, reinforced with dozens of Panther tanks, the armored pride of the Reich, with its 75-meter high-velocity guns and almost impenetrable frontal armor. On the other, the American 4th Armored Division, operating in open terrain with technically inferior Shermans, armed with 75mm cannons that could barely pierce the hull of a Panther for more than 500 meters. If war were a mathematical equation of steel, range, and power, German victory would be inevitable. But it didn't come. What happened at Aricourt was more than an American tactical victory. It was a surgical demonstration of how the communication network could subvert the traditional logic of the battlefield. The Panthers pushed forward confidently, believing they were facing a fragmented and unprepared force. What they found was an invisible trap, not made of mines or trenches, but of data and coordination. Every enemy position spotted by an American observer was immediately reported via radio. Within seconds, this information was relayed to artillery, nearby tanks, and air units on patrol. The network was alive, and the Panthers were visible. The M7 Priest and M10 Wolverine artillery units positioned behind the front line adjusted fire based on real-time corrections provided by SCR 300 and SCR 528 radios, and the result was brutal. Entire columns of German tanks were hit even before going into direct combat. The sound of the engines was drowned out by the roar of precision. The commander of the 111th Panzer Regiment later reported that American artillery fire seemed to follow us, as if it knew where we were going to turn before we decided. And he knew. American coordination had reached such a level of integration that at many times the Sherman tanks themselves did not even need to fire to win. It was enough to locate. The fire came from the sky, or from the soil, but always at the right time. One technical fact sums up the German tragedy. In just 10 days of fighting, the U.S. destroyed 86 German tanks and armored vehicles at Ericourt, losing only 25 Shermans, and much of those losses by ambush fire, not direct confrontation. Even where the Germans managed to fire first, the American response was fulminant. What's more, with so many radios operating simultaneously, American platoons were able to redraw the battlefield in real time. When a position was compromised, the maneuver took place in seconds, with tanks reacting in a block even without visual contact. The Germans were watching a mechanical ballet, precise, invisible, and relentless. And here, a break from the logistical reality. While Germany could barely produce 80 Panthers a month in 1944, the U.S. was manufacturing more than 1,000 Sherman tanks in the same period, as well as industrial-scale trucks, radios, spare parts, and ammunition. The result was not just quantity, it was continuity. While the Germans were hesitant to move forward without clear communication, the Americans had operational confidence because they knew they could meet, regroup, reorganize, because they were connected. If this statistic surprises you, write in the comments, "Shocking data." That's the difference between a war machine and a war network. In Ericourt, technology compensated for every mechanical weakness of the Shermans. The lower armor was compensated for by quick maneuvering, the limited range of the cannon by advance information, vulnerability to ambushes by integrated aerial reconnaissance. Each piece of the system knew where the others were, and every order, every call for fire, every flank alert, traveled faster than enemy tanks could move, and because of that, the Panthers didn't win. They were defeated not by force, but by predictability, out of arrogance, for underestimating an enemy who, although he didn't have the best tank, had the best system. But the Germans still believed that their problems were momentary, that it was enough to reorganize, regroup, redirect its elite forces. They didn't know that the next American wave would come even more coordinated, and not just with tanks and planes. Radio would now unite the battlefield with something even bigger, the industry itself, because the next American weapon would not come from the barrel of a cannon, but from the assembly line, and the radio would be the link between the soldier and the factory. In World War II, time was more than a variable. It was a weapon, and in 1944, this weapon belonged to the Americans. What German troops experienced as a series of tactical coincidences, sudden bombardments, unexpected flanks, artillery that appeared seconds after a position was detected, was actually the reflection of a system that had shortened the distance between vision and action to an almost instantaneous level. At the heart of this system was the SCR-508 radio. With a range of up to 25 kilometers in ideal conditions and the ability to communicate simultaneously between armored vehicles, commandos, and observers, the SCR-508 worked like an invisible clock, synchronizing hundreds of units spread over kilometers of varied terrain. While the Germans still relied on fragmented systems, messenger orders, or single channels that required rigid command sequences, the Americans operated on multiple frequencies, with redundancy and decentralization. This meant that in the face of a sudden threat, an infantry platoon could report its position, call for tank support, and coordinate an artillery strike, all in less than 5 minutes. Compared to the German model, where orders had to go through at least 2 levels of hierarchy and fire orders were recorded manually, the difference was brutal. In a post-battle report of the American 3rd Armored Division, it was recorded that the average time between the first visual contact with the enemy and the firing of the first artillery shell was only 4 minutes and 38 seconds. The German average in the same scenarios exceeded 25 minutes, when there was no interference, and that time was everything. An open flank for 5 minutes is an opportunity. A flank opened by 25 is a death sentence. In battles like St. Lo, this military time redefined the concept of superiority. While the German commanders were still calculating distances and waiting for radio confirmations, the Americans had already identified the target, triangulated the position, and executed the attack. In many cases, the response time was so fast that the Germans believed they were facing real-time espionage. They weren't. They were facing an enemy that operated as an organism. Every soldier, every tank, every piece of artillery was a neuron. The radio was the nervous system, and the brain, decentralized, was in the field. General George Patton described this capability in a phrase that captured its brutal essence. They see us. We listened. They move. We fired. That was the American reaction cycle. See, communicate, act, in less than 5 minutes. By comparison, General Bayerlein, commander of the Panzer Lehr Division, confessed after the war that our armor was sometimes hit before we even saw the Americans. It was like fighting a force that already knew you would come. And, in fact, he knew. The Sherman's antennas, the scouts' radios, the eyes of the forward observers, all transmitted simultaneous signals, powering a system that worked even under fire, even in fragments. The redundancy of the American system was such that even if 2 or 3 tanks were destroyed, communication persisted. The breakdown of the chain of command, which was a constant risk in the German model, was almost impossible in American networks. This structure, fueled by a constant flow of information, transformed the American command into something unprecedented, an army with reflexes. Instead of relying on formal orders issued from afar, decisions could be made in the field, based on real data, in real time. Platoon commanders had freedom, and, more importantly, they had information. The American doctrine's reliance on decentralization only worked because the radio ensured that all levels of the chain knew what was going on. It was the end of the war for maps, and the beginning of the war by waves. The difference between thinking and reacting has become imperceptible. At Mortain, for example, a German attempt at a coordinated attack failed before it even formed. Air observers identified the movement, transmitted the information to units on the ground, and, in less than 6 minutes, the concentration area was bombarded by 3 artillery batteries. The attack died before it was born. The Germans, isolated in their doctrinal fragments, were never able to understand how their initiatives disappeared. They still played chess. The Americans, with radio and time, played blitz. The irony is that Germany had been the first nation to understand the potential of radio in mobile warfare, but in 1944, due to lack of scale, industrial prioritization, and flexible doctrine, they handed this weapon over to the enemy. And the enemy didn't just use it, it turned it into the pulse of war. But the synchronization of armor and infantry was only the surface. The true impact of radio was yet to come. Because if an army can think in seconds, what happens when it can also rebuild itself in days? When the radio not only guides tanks, but also supplies factories, plans replacements, coordinates the repair of hundreds of vehicles simultaneously. The next part of the war would not be decided by what was already in the field, but by all that was yet to come from the production lines. March 1945. On the banks of the Rhine, the last natural obstacle between the Allies and Germany's industrial heartland, a miracle of German engineering survives the chaos. The Ludendorff Bridge in Remagen is still standing. The bridge, built to carry troops and heavy loads in World War I, had been mined by German engineers but had not yet been detonated. It was a narrow window of time. The Germans saw it as a lost point. The Americans, as an open portal to the end of the war. At 1:50 p.m., on March 7th, an advance patrol of the U.S. 9th Armored Division arrives on the hill overlooking the city. When they see the bridge intact, the first reaction is not attack. It is transmission. A single report, sent by the SCR-528 radio installed on an M4 Sherman tank, sets in motion a chain of events that would change the strategic course of the Western Front. In a matter of minutes, the information reaches the headquarters of the 1st U.S. Navy. In less than an hour, entire divisions begin to reroute their routes. Radio turns luck into decision, opportunity into operation. Colonel Hogue, commander of the reconnaissance force, receives the order over the radio. Advance immediately. Take the bridge. There was no time for committees. There was no time for traditional planning, but there was radio time, and that was enough. At 3 p.m., the 1st American company steps on the bridge. German troops fire from the opposite side, trying to contain the crossing, but American coordination kicks in. Sherman tanks deploy for cover, artillery is radioed by observers ahead of a few miles, and infantry units traverse in sequence. The Germans try to detonate the explosives. The system fails. The structure resists. The crossing continues. In less than 12 hours, more than 8,000 American troops cross the Rhine. And the most impressive thing is not just the audacity, it is the fluidity. Every movement, every boost, every reallocation of ammunition and fuel is guided not by messengers, but by electromagnetic waves. Tanks are no longer just weapons. They are mobile command and control nodes. Each vehicle carries a radio. Each platoon commander knows the situation. War, for the first time, ceases to be a set of isolated battles and becomes a continuous, fluid operation, coordinated by an invisible backbone, the radio spectrum. Meanwhile, the Germans, taken by surprise, live the opposite. Its communications, based on already bombed telephone lines, take hours to reach higher commands. Intercepted messages reveal confusion, misinformation, and contradictory orders. In a desperate excerpt, a German officer informs him that reinforcements are on the way, when in fact the assigned units had been redirected without his knowledge. The system does not respond. Time evaporates, and the bridge remains. General Eisenhower would later say that the Remagen Bridge was worth an entire division. But what kept it alive wasn't just its structure, it was the speed with which the Americans transformed it from a target into a strategic tool. This speed was not instinct, it was a system. The radio was the link between chance and victory. And here comes a brutal comparison. While the Germans were still trying to send reinforcements by rail, the American command had already deployed tanks, pontoon bridges, anti-aircraft units, and supply lines over the Rhine, all in less than 48 hours. And all guided by a communication mesh where each party knew what the other was doing. If the Remagen crossing seems like a feat of courage, that's because it is. But it is also a feat of logistics, technology, and coordination. The three pillars that the German doctrine, once so advanced, had lost through wear and rigidity. German General von Zangen would later write, "The bridge fell not because it lacked courage, but because we didn't know. We didn't know they were coming. We didn't know they were already there." The defeat, in this case, was a defeat of perception. And the radio, more than a technical tool, was the lens that allowed Americans to see the battlefield as it was, in real time. The crossing of the Rhine was not just a military passage. It was the silent announcement that Germany was, at last, surrounded, not just by troops but by a system that knew where it breathed. But the war was not yet over, and what would come next would show that, even in the final days, American radio would still have one last function: to reveal, coordinate, and decide the fate of entire cities. Because radio didn't just win battles, it began to shape the occupation. In the final months of the war, the German High Command was beginning to recognize something that had previously been thought impossible. The defensive lines were crumbling, not just by brute force, but by an enemy capability they couldn't name. In intercepted reports and seized diaries, repeated descriptions emerge, often loaded with perplexity. Americans move too fast for geography to allow. Their fire support is instantaneous and always accurate. There is no discernible logic in the movement of the armored vehicles, only an apparent ubiquity. But what the Germans described as chaos was actually the invisible order of a connected doctrine. In Berlin, Wehrmacht intelligence memos warned of the unusual ability of the Americans to react to attacks with coordinated force in less than 15 minutes. The term unusual revealed more than admiration. It revealed blindness. They saw the effect, but they didn't see the cause. While generals discussed doctrines and remade maps in heavily curtained halls, Sherman tanks and their crews operated as nodes of a moving network. And this network, silent and constant, was supported by an element that German doctrine despised for too long: radio as a system. American technology was no longer just a tactical differentiator. It was a new language of warfare. And Germany, arrogant in its traditionalist vision, spoke a language that the battlefield no longer understood. The irony of this story is that the solution was in front of them. Heinz Guderian, the architect of the Blitzkrieg himself, had written in 1937 that the key to the war of movement is the radio. But over the years, this vision has been sacrificed on the altar of scarcity, bureaucracy, and the illusion of technical superiority. By 1945, while the Americans were producing and installing more than 50,000 units of SCR radios per quarter, German industry was struggling to replace even the obsolete FUG-5 models. The Wehrmacht believed it was fighting against excess material. But it wasn't the volume that won. It was the connectivity. The radio was not an accessory. It was the gun itself, and this the German reports did not understand. In a March 1945 document, a colonel in the 11th Panzer Division describes the American move as mechanically improbable. He wasn't wrong. It was mechanically improbable, for a mind trained in the limitations of its own doctrine, but absolutely plausible for a force where each unit knew in real time the position and intention of the others. That was the real American disruption, distributed decision warfare, where a platoon of tanks could change the course of a battle, not by chance, but by access to information. And the more the Germans tried to explain this away with terms like discipline or over-equipment, the farther they got from real understanding. What they called luck was actually real-time planning. What they saw as confusion was controlled flexibility. And what they classified as American improvisation was, in fact, a coordinated execution between mobile units connected by safe frequencies. If you're enjoying unraveling these facts that never made it into school textbooks, show your support. Like and subscribe so we can continue to reveal the unseen backstage of the war. Because sometimes, the most decisive story is the one that doesn't appear on the maps, but on the waves. Most devastating, however, was what the Germans did not say. Because in the reports and diaries captured, the scariest pattern was not error, it was silence. In no technical document does there appear a real suspicion that the radio was the center of the enemy system, not because of censorship but because of cognitive limitation. The technological empire of the Third Reich, so proud of its V-guns, its impenetrable tanks, and its jet planes, never considered that it was being defeated not by what it saw, but for what he did not hear, and when they finally realized it was too late. Radio was no longer just a force multiplier, it was the central structure of a new type of war. But the American signals were not yet over, because the latest U.S. offensive would require something beyond tactical coordination. It would require the fusion of the battlefield and the factories, between the operator and the arsenal, and the radio, once again, would be the driver of this transformation. As the world looked at the front lines, at the maps covered in arrows and divisions, at the tanks exploding in forests and razed cities, another war was won, away from the sound of cannons. It was a war made of welding, precision, and scale. In the industrial heart of Chicago, a red brick building housed a factory that, at first glance, seemed just one of many in the American war effort. But inside, Motorola, still officially called Galvin Manufacturing, was conducting an operation that would redefine modern combat power. It was not a question of making tanks, but of giving them a voice. More than 50,000 units of the SCR 508 radio would be produced at that facility alone, an almost obscene number when compared to the production of German radios, which barely reached the mark of 10,000 units per year at its peak. Each SCR 508 was a meticulous piece of engineering, with more than 1,200 hand-welded components, calibrated with crystal oscillators and shielded to resist vibration, heat, and impact. Most importantly, each of these radios left the factory tested, tuned, and pre-configured for standard operating channels, ready to be installed in any Sherman tank with minimal retrofit. The radio was not an optional accessory, it was a native function of the vehicle, and this seemingly technical detail revealed something bigger. The Sherman wasn't just a tank, it was an armored network terminal. Contrary to what many believe, the United States did not win the war just by doing more. They won by doing better at scale. While Germany had to adapt, improvise, and rebuild under constant bombardment, the U.S. built with redundancy. For every radio that malfunctioned, another was ready to replace. For each platoon, there was double coverage. And this happened because the American production line was designed as part of the doctrine, not just logistics. Motorola, in conjunction with the War Department, implemented a real-time feedback system with troops. Each batch of radios sent to the front returned with technical reports, failures, suggestions, wear and tear. From there, engineering adjustments were made weekly. In the middle of the war, the SCR 508 version evolved more than 7 times, with improvements in electromagnetic shielding, power consumption, and signal range. None of these decisions were theoretical. They all came from the real war, and returned to it in a matter of days. This continuous cycle between combat and factory has created a mission-driven innovation ecosystem. And here is the fact that sums up this abyss between the two sides. While Germany lost 2 to 3 months to approve technical modifications via military bureaucracy, the U.S. implemented new versions of its radios in less than 15 days, from the test bench to the assembly line. This agility, imperceptible to the eyes of the enemy, was the real engine behind the tactical omnipresence that so confused the German generals. The radio didn't just connect the tanks, it connected the front line to industry, and this connection was more powerful than any shield. By 1944, American industrial production had reached its peak, 2,500 Sherman tanks a month, all radio-based, all standard-channeled, all integrated. This wasn't excess, it was strategy. While the German Panthers arrived at the front as isolated pieces, dependent on fragile logistics chains, the Shermans arrived as members of an organism, ready to act, listen, and respond. And this organism had a nerve center, frequency. When an American lieutenant asked for support, he did not wait hours for a response. He was coordinated in seconds, because the factory in Chicago, and dozens of others scattered across the country, had secured it even before he landed in Europe. The victory at Aricourt, the crossing at Remagen, the sieges at Mortain and Falaise, all these moments had radio as a common link, and all these radios had their origins in the same philosophy. The war of the 20th century would not be won only by tanks, but by systems. Motorola understood this, and so while Germany saw its engineers being shifted to V-weapons, rockets, and megalomaniacal propaganda projects, the U.S. was betting on something almost invisible, but vital, the voice. The voice of the platoon commander, the gunner's voice asking for coordinates, the voice of the tank retreating for maneuver, and all these voices traveled through the fields of Europe through a crystal chip assembled by workers in Chicago, on production lines that did not stop even at night. War was no longer linear. It was digital, in the technical sense of coordination, signal, precision. And the Germans, as much as they tried to understand, kept aiming at the tank, without realizing what was inside him. A German general captured in April 1945 was blunt in his assessment. "We didn't lose to the armor, we lost to the speed of response." And this speed of response did not come from the front, it came from the rear. The American industry was talking, and the tanks listened. But there was still one last lesson missing, because the radio, in addition to connecting, also selected who led. The last stage of the war would prove that force was not enough. It needed intelligence and distributed command. And America was about to show how even the youngest sergeant could win battles, if it was connected. The decentralized command doctrine that today underpins NATO operations, real-time data-driven missiles, and network-centric warfare systems was not born with satellites. It was born with copper wires, vacuum valves, and welded metal knobs inside Sherman tanks in 1942. What seemed at the time to be a simple tactical advantage, tanks communicating efficiently, turned out to be the foundation of a new way of thinking about war. For the first time, a ground force operated not as isolated columns, but as an organic network, and radium, especially SCR-508, was the connective tissue of this structure. Each platoon could function as an autonomous cell, reacting to the environment, adapting to the enemy, and sharing information in real time. This created a battlefield where superiority was not only measured in the number of guns, but in the speed at which decisions propagated. And it was exactly this doctrine that the U.S. carried into the future. When helicopters coordinated raids and evacuations during Vietnam, they were applying the same distributed command logic tested in the Normandy camps. When M1 Abrams tanks operated in a network in the Gulf War, integrating sensors, GPS, and digital radio commands, they were continuing what began with Motorola's first FM radios. In contrast, German doctrine died with its armor, its vertical, rigid, and centralized model, where the destruction of the commander collapsed the entire unit, proved to be not only vulnerable, but obsolete. Germany had put its resources at the tip of the spear: armor, penetration, speed. The U.S. built the cable that connected all the spears, and that therefore won even when each individual spear was lower. The result was a historic reversal. The country with the weakest tanks won the armored war with coordination precision, and this feat left lasting marks. In post-war American military academies, case studies of World War II did not focus solely on strategy. They focused on systems, in how to communicate, react, synchronize. And with it was born the command mission doctrine, where orders are given on objectives, not methods, and where tactical initiative is a virtue, not a threat to hierarchy. This doctrine is only possible when there is trust and communication. Radio made this possible. It allowed you to decentralize without losing control, and it was this philosophy that shaped the military structure of the Western powers in the following decades. It is no coincidence that the FM 105 Manual from 1986, a doctrinal document of the U.S. Army, dedicates more pages to tactical communication and interoperability of systems than to the description of offensive maneuvers, because the war of the future would no longer be decided only by who shoots first, but by who coordinates best, and that lesson was not learned in the Gulf nor in Afghanistan. It was forged in the Motorola workshops, in the fields of Kasserine, and in the streets of Aachen. While Germany saw the war as a sequence of battles, the U.S. began to see it as a real-time system. The Sherman's radio was not just a technical advance, it was a strategic statement. Strength is in connection, and if in 1942 this seemed like an isolated innovation, today it is a universal principle. In the end, it was not armor, caliber, or speed that defined the military 20th century. It was the invisible sound of coordination, and what the Germans never understood. It still echoes in today's doctrines, but there was more. Because that network created between the Sherman tanks didn't stop there. It would soon connect all spheres of American military power, from infantry to aviation, from logistics to intelligence. And at the climax of the war, this entire network would be set in motion for one last decisive move. The final victory would not be won by one big gun, but by an entire system acting as one. And that moment was about to come. In every battle where the American flag advanced, there was an invisible line drawn between the machines and the men, a line the Germans never saw. The thin black antennae, mounted discreetly on each Sherman's hull, were there from the start, fluttering with movement, almost like a decorative detail, and even so, they were ignored. At Kasserine, the panzers saw enemy formations move like swarms, and attributed it to chance. At Falaise, they saw the artillery respond accurately within seconds and called it luck. At Aricourt, they saw the chaos of battle tilt toward the Americans as if someone were driving over the top, and they assumed it was their own mistake. But it wasn't magic. It was connection. The secret weapon was in plain sight, displayed on top of every tank, in every mechanized column, in every command truck. And yet, it went unnoticed. The German obsession with technical weaponry, high-velocity cannons, tilted armor, precision optics, created a selective blindness. For them, war was decided by the range of the projectile, not the speed of information. It was overcome by the impact of the explosion, not by the precision of coordination. It was dominated by machines, not networks, and that's why they never understood. A March 1945 Wehrmacht intelligence report described American behavior as standardized but surprisingly effective. In other words, they saw the effectiveness, but they did not understand the mechanism. There was no room in the German doctrinal vocabulary for the idea of a tactical network, only for hierarchical orders. When they saw a Sherman platoon maneuver independently and still maintain cohesion, they interpreted it as the exception, not the rule. But that was the rule. It was doctrine, built on paper, implemented on copper, and tested on steel. Modern warfare had been revealed, and they were looking the wrong way. What looked like American disorganization was actually intentional decentralization. What seemed like excess material was actually functional redundancy, and what seemed like improvisation was, in fact, radio coordination, planned, systematized, and delivered with mathematical precision. The most ironic thing is that Germany knew the importance of radio. Heinz Guderian, decades earlier, had written that radio would turn speed into victory, but German industry could not keep up with the vision. The Fu-G5, the main radio of the Panzer tanks, was a respectable piece in 1937. In 1944, it was a breathless noise amid the thunder of the battlefield, limited to 2.5 watts, with no stability crystal, with an actual range of less than a kilometer over uneven terrain. It was the equivalent of trying to command a symphony with a rusty whistle. The SCR-508 from the Americans operated with 25 watts of pure FM power, modulated by crystal, resistant to atmospheric interference and with multiple channels. It was literally another technological era, and it was everywhere. Mass production didn't just guarantee scale, It guaranteed standardization. Each unit could connect with another instantly. Officers could move between tanks and maintain communication. Units from different battalions could share frequencies. It was the opposite of German rigidity, and exactly what the war demanded. With each passing week, the American network became denser, more connected, more responsive, and ironically, more invisible. The Germans were looking for larger tanks. They expected ambushes. They foresaw tactics, but they never looked for the radio. They never suspected that what won the war was not a new type of weapon, but a new way of thinking. By April 1945, the war was already decided, not because American tanks were tougher, nor because the soldiers were better trained, but because each of them was part of something bigger, and he knew it. An army that shares information wins. A platoon that adapts in real time survives. A force that speaks, listens, and decides, changes the course of history. And while the Germans tried to understand how they lost to the lower tank, the antennas on the Shermans kept transmitting. One of them even transmitted the last request for surrender of the German garrison in Remagen. It wasn't intercepted by chance. It was heard because the American network was everywhere. They never looked at her. They never understood what they were facing, and what they lost. I was in front of them all the time. But there was still one last revelation. Because even after the victory, few publicly recognized the importance of radio. It did not make headlines. It did not gain a monument. But those who fought knew, and a forgotten confession in a post-war report carried the final lament of a German officer. We have never seen antennae as weapons. Now we know they were. By the end of 1945, there was no longer any doubt in the raised camps of Europe. Germany was not defeated only by tanks, planes, or bombing. It was defeated by a doctrine that it failed to see. The ideological collapse of the Wehrmacht did not occur when its armor was destroyed, but when its tactical pride was dissolved by the invisible efficiency of a network. The M4 Sherman, symbol of mass war, revealed itself not as a lone war machine, but as a link in a larger organism. While the Germans operated under the belief that strength would come from individual technical superiority, the Americans won by thinking collectively, an army that listened, spoke, and acted in unison. The lesson of this war is brutal in its simplicity. Logistics determines strategy, but communication determines victory. No general wins in a vacuum. No tank fights alone. The modern battlefield belongs to those who move as a network, not as a collection of parts. World War II was the milestone where the radio ceased to be an accessory and became a weapon. An army that speaks wins. An army that hears survives. And an army that connects, turns its weaknesses into strength. German General Alfred Jodl, already a prisoner, summed up this collapse with a lament that carried more weight than he imagined. We were defeated by trucks, radios, and engineers. If this story has impacted you, help keep alive the memory of the facts that shaped our world. Like this video, subscribe to the channel, and activate the bell so you don't miss the next devastating historical fact. And say in the comments, what is the most shocking fact of this silent story that changed the course of the war? Don't go away yet. Listen to the next true story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.